Did you know that in a year, smokers receive a radiation dose equivalent to about 300 chest x-rays due to the radioactive isotope polonium-210 contained in tobacco smoke that comes from the ingredients of the fertilizers that are used in tobacco farming? Hi, welcome to another episode of Chemistry is Easy with Mr. Jesse. For this tutorial, I'm going to cover the following objectives. First, describe radioactive decay series and use this graph to determine the type of decay and when it ends. Next, define half-life of a radioactive isotope and calculate the half-life, remaining amount of an element, and the original amount of a radioactive element. First in our list of objectives is radioactive series. Now, radioactive decay series is just a series of nuclear reactions that begins with an unstable nucleus and results in the formation of a stable nucleus. So again, this is called radioactive decay series. So here we have below is a graph that indicates the radioactive decay series of uranium-238. So we have here the graph shows uranium-238 first decays to thorium-236. So this is thorium-234. That's thorium-234. We have here the mass number, and on this side is the atomic number. After that, thorium-234 decays or undergoes beta decay to become protactinium-234. So we have here protactinium-234, and then after that, the decay process continues until such time that a more stable isotope, which is lead-206, is formed. Now take note that the red arrow indicates the alpha decay, while the blue arrow indicates beta decay. Now let's move on to radioactive decay rates. Radioactive decay rates are measured in half-lives. Now a half-life is the time required for one half of a radioactive isotope or a radioisotope to decay into its products, and it is governed by this equation. So we have capital letter N is equal to N sub 0 multiplied by the quantity of 1/2 raised to the power of a small n, or we could also say that the capital letter N is equal to N sub 0 multiplied by 1/2 raised to the power of small t divided by capital letter T. Now, the capital letter N is the remaining amount of radioactive isotope. N sub 0 is the initial amount of the radioactive isotope. The small letter n is the number of half-lives that have passed, and the small t is the time elapsed, and the capital letter T is the duration of the half-life. Now here is an example. Table 24.4 shows the decay of strontium-90. Now the half-life of strontium-90 is 29 years. So meaning, if the initial amount of strontium is 10 grams, after one half-life, that is 29 years, after 29 years, half of the initial amount would remain and the other half would have decayed. After another half-life, that is after two half-lives, that means 58 years. After 58 years, only 2.50 grams will remain. So that is half of 5 grams. Now, after the third half-life, that is 87 years, because that means 29 times 3, that is equal to 87 years. Half of 250 would remain, and that means after 3 half-lives, we will have 1.25 grams of strontium-90 remaining. And after the fourth half-life, that means 4 times 29, which is equal to 116 years. Half of what has remained after 87 years, that means half of 1.25 grams would decay, and therefore After 4 half-lives, only 0.625 grams will remain. So that is the idea of half-life. And different substances would have different half-lives. Again, different substances or different radioisotopes have different half-lives. Some isotopes would have very short half-lives, like polonium-214. Its half-life is only 1.63.7 micro of a second, while other radioactive isotopes would also have very, very long half-lives, just like uranium-238. Its half-life is 4.46 times 10 to the power of positive 9 years. So again, different substances will have different half-lives or different amounts of time for its initial amount to decrease by half. So here is a sample problem. An unknown element has a half-life of 40 years. How much of a 20.0 gram sample will be left after 120 years? So we have the half-life, or capital letter T, is equal to 40 years. And we have the initial amount of radioactive isotope, that's 20.0 grams. We are also given the time elapsed, or the small letter t, which is equal to 120 years. And we are asked how much of the 20 gram sample will be left after 120 years. So therefore, we are actually going to solve for the capital letter N. Now, we have recalled that our equation for half-life is capital letter N, or the amount of radioactive isotope remaining is equal to the initial amount of radioactive isotope multiplied by 1/2 raised to the power of the time elapsed, or small t, divided by the half-life, which is the capital letter T. Now let us just substitute our values. N sub 0, or the initial amount, is 20 grams multiplied by 1/2 raised to the power of small t, or the time elapsed, which is 120 years, divided by 40 years, which is the half-life of this radioactive substance. And that gives us 20 grams multiplied by the quantity of 1/2 raised to the power of 3. So therefore, we will have the remaining amount is 2.5 grams. And that is letter B. Here is another sample problem on half-life. It reads, if the passing of 5 half-lives leaves 25 milligrams of strontium-90 sample, how much was present in the beginning? Now let us analyze this problem. So we have here, if the passing of 5 half-lives, that means we have our small n, or the number of half-lives, is equal to 5. And it says it leaves 25 milligrams of strontium-90, so meaning that is our remaining amount of radioactive isotope, that is 25 milligrams. And we are asked how much was present in the beginning. So therefore, we are going to solve for the initial amount of radioactive substance. Now recall that our equation is N, or the amount of radioactive substance remaining, is equal to the initial amount of radioactive substance multiplied by 1/2 raised to the power of small n, or the number of half-lives that have passed. And recall, by the way, that n is, or small letter n may also be equal to small letter t divided by the half-life, but in this case we are already given the number of half-lives that have passed, so we would use this equation. Now let us substitute our values now. We have our n, or the amount remaining, is 25 milligrams, and we are going to solve for n sub 0, or the initial amount of radioactive isotope, multiplied by 1/2 raised to the power of 5, since it says here that 5 half-lives have passed. So let us manipulate or simplify this equation. That's 25 milligrams is equal to n sub 0, and 1/2 raised to the power of 5 is equal to 0.03125. And moving on with our calculation, we could divide both sides by this quantity over here, so we will have 25 milligrams divided by 0.03125, and that is equal to n sub 0. We have 0.03125. We'll also divide this side by 0.03125. We could cancel that out, and then this finally gives us 800 milligrams, and that is equal to n sub 0, or the initial amount of the radioactive substance. So this is the amount that was present in the beginning. And that concludes this tutorial. Once again, always remember, chemistry is easy with Mr. Jesse.